the third line there where Cn is equal to 1 by 2 the whole bracket
Yeah.
e power minus 1 plus I n omega x divided by minus 1 plus I
Yes.
n omega.
Yeah. So that
So
is because of integration.
minus no sir, a minus comes out.
Sorry?
So there's a minus that comes out.
Yeah.
But in
So
the next line, you rationalize the entire complex number, but where does the minus go, sir?
so minus is, I wrote minus. Here only it is there. So minus remains same. Minus 1 over. So this minus goes to numerator. Can you see? In the numerator I wrote minus.
Yes,
So
sir,
it
that
is,
goes to the numerator.
yeah, 1 over that 1 by 2 is there. So divide in the denominator it is 2 times 1 plus I n omega.
Yes.
Okay, then I apply the limit. When you put an upper limit x equal to 1, so that becomes e power minus of 1 plus I n omega.
Okay,
Okay,
so we have applied the limits. Okay, sir.
yeah, when you put a lower limit, so that is minus, take a lower limit. Lower limit is minus 1.
Yes,
Okay,
sir, so it becomes plus.
so that becomes plus into 1 plus I n omega. Okay, so then
Okay, sir.
now I need to expand this e power minus 1 into e power minus. So because this minus has to multiply in both the terms, so that is e power minus I n omega minus e power 1 into e power plus I n omega. So that is second term in the next line. And when you come to the first term, we have, so this is, yeah, here I missed the minus sign.
Yes, sir, that's what I was going. The next answer also is kind of
Yeah,
neglecting.
here I missed, in the second line I missed the minus sign. So that is 1 minus, it should be minus 1 over 2 times 1 plus I n omega into, so this is rationalization of a
Yes, sir,
complex.
rationalization.
Okay, so this will be, as I explained, e power minus I n omega and e power I n omega, both term becomes cos n pi. So that is okay. So I have missed the minus sign in the next line onwards. I'm sorry. So finally, I think next
The
slide,
answer will be negative.
yeah, everything will be multiplied with negative 1. I'm sorry. So shall I do it this once again? Muhammad,
No, sir,
shall I
I guess.
solve this problem again?
No, sir, it's not necessary, I guess. What about the others? What ask them?
Sorry?
So, what about the rest? If they want it, I'm fine with it.
No, if you
No, sir,
want,
no, sir. No, sir, it's not necessary.
okay. Then shall I take another problem?
Yes, sir, new problem.
Okay, thank you. I'm sorry, I just missed the negative side here. Okay, so before start the class, so just announce you, I have shared the link of Peak Cloud. So in that link, you have to upload your assignment. So that I think you have already received assignment copy. And also, I'll share the format in that group now. So you either you have to take print out the format, or you can write the same format in your white pages. So suppose you want to write in a white pages, you can use white pages to write the content what I am given here. Otherwise, you can in a blue book also you can write. So if possible, if you want to take a printout, you can take a printout of this template and you can write. So you have to follow this template. Either you can write manually or you can take a printout. Whatever it is possible to you, you do it. I am not forcing you to take printout also. So if you like to write, definitely you can write. And so once you write the assignment, I mean once you solve the questions given in the assignment, so final copy you have to scan the copy as all the copies and make a PDF. The file name of the PDF should be your name and registration number, and that copy you have to upload in the given link. So the deadline is the 30th of this month. The only 2 more days you have. So please, I mean, try to adhere to that deadline. Don't ask exceptions. So because we have only 2 questions, roughly if you go sit and solve, it will take within 30 minutes you can solve. So the problems are similar problems we have solved. Okay, I think if you have any doubt while solving the assignment questions, definitely you can ask through WhatsApp. So I will help you. Is that clear? So I have shared the link also, and the format is just now I have shared in the group. You follow that format. So each page should be contain your name and registration number. Whatever, how many page you would like to use, you can, but each page should contain your name and registration number. And first page, what we have given in the template, that is the first page of your assignment. And another important is you have to keep your hard copy safely. So when you come to the campus, you have to submit the hard copy. So don't misplace the.
So what if we just do it in the blue book, sir?
Yeah, if you that is the good idea. If you maintain, I mean, if possible, so it is not possible to all. If possible, better to buy a blue book. In each starting of the assignment, you have to write that copy. Otherwise, in the first page you write that copy, and you can later you can just first page you always take a PDF copy. I mean, scan copy, and rest of the remaining pages wherever you started. So that also you can scan and make a PDF all the files. So it is, if you possible, buy a blue book. If it is not possible, you can use white sheets. So that sheet should be maintained. I mean, you have to safely keep that sheets. So because this time, I mean, I am not telling you to compulsorily buy a blue book. If you possible, you please buy a blue book and answer the assignment question. And first page of your blue book is what I have given a format. It should contain that one. And rest of the pages, as usual, you have to maintain your registration number, name. So because I mean, since it is online content, if it is overlap or something misplaced, even I mean, in the PDF it is not possible. You may say the answer in the PDF is not possible, but as a evaluation, as a person I am doing evaluation, I must need the details. Okay, so that's all the information regarding the assignment submission. And now I'll continue the complex Fourier series. So I think we have discussed one example in the complex Fourier series, and that is so I think now e power minus x. So I think we have missed the sign. So finally we got this term. So it was reversed in our case. So we got it is in minus 1. When you take negative sign, so this will be the correct answer. Okay. So let me take another example. Obtain the complex form of the Fourier series of the function. So there is a rectangular function, rectangular waves. So minus pi to pi. Take an example. So the problem is obtain. I'm sorry, just a minute. I'll share the screen and I'll start that. So take an example. Obtain the complex Fourier series expansion of f of x equals minus 1 in the interval minus pi less than x less than 0 and 1, 0 less than x less than pi. So here is also condition f of x plus 2 pi is f of x. So that period is 2 pi. So we need to find a complex Fourier series, and this function is a rectangular wave. If you draw the graph of this function, we have shown you that is minus pi, 0 and pi. So from minus pi to 0 it is minus 1, so this is minus 1, and 0 to pi it is plus 1, so this is 1. And if you want to extend this series, so this will be the extension of periodic function. So then it goes like this, so like this, so it looks like a rectangular pulse. Okay, so now we need to find a complex Fourier series. So solution, we have the definition of, we have complex Fourier series. So that is f of x equals summation n running from minus infinity to plus infinity Cn e to the power I n omega x, Cartesian equation 1, where Cn is 1 by t integration from c to c plus t f of x into e to the power negative in omega x into dx. So here omega is 2 pi by t, and this is, since period is 2 pi, so omega value is 2 pi by 2 pi, so omega is 1, so is the omega value, and therefore so function is defined in the interval minus pi to pi. So therefore Cn is 1 by 2 pi integration from minus pi to pi f of x into e to the power in x. So since omega value is 1, dx. And now our f of x is piecewise function, so we need to split the integral in the interval minus pi to 0 and 0 to pi. So that will be 1 by 2 pi integration from minus pi to 0 f of x into e to the power minus in x dx plus 1 by 2 pi integration from 0 to pi f of x into e to the power minus in x dx. So the function in the interval minus pi to 0 is minus 1. So this is value of function is minus 1, and this value is plus 1, that is 0 to pi. So that becomes minus, so that is 1 by 2 pi. I will write minus pi to 0, or you can change that interval also, minus pi to 0. So this is negative e power minus in x into dx plus 1 by 2 pi integration from 0 to pi 1 into e power minus in x into dx. Okay, so now we need to integrate so e to the power minus, so that will be, so this is equal to 1 by 2 pi into integration of e power minus in x is, so minus e to the power minus in x divided by minus in. Okay, and limits from minus pi to 0. Next plus 1 by 2 pi integration of e power minus in x is e to the power minus in x divided by minus in, limits from 0 to pi. So when I apply the limit, so this is minus minus get cancelled, so 1 by, so in both the numerator it is 1 by 2 pi in, so I can take 1 by 2 pi in It's common 2 pi in. So now minus this will be plus. When you put an upper limit e power 0 minus, when you put a lower limit e power in pi. So here minus pi and minus becomes plus. Next is, so this sign is, we have negative because we have a negative here, so this becomes minus of upper limit. When you put an upper limit, it is e to the power minus in pi, and minus lower limit gives e power 0. Okay, after simplification, so I'll write in the next slide. So 1 by, again 1 by I is minus I, so that can be written as minus I divided by 2 pi n into, so e power 0 is 1 minus, again we can see e power in pi. So e power in pi is, so e power in pi is nothing but cos n pi plus I sin n pi. Again sin n pi is 0, so we get minus 1 power n. Even this is same as e power minus in pi. Both will get a minus 1 power n. So this is minus 1 power n, and here is also minus 1 power n. So e power 0 is 1 minus minus 1 power n, again minus minus 1 power n, and next last term is plus 1. So minus minus 1 power n minus again minus 1 power n plus e power 0 is 1. So that becomes Cn is, so that will be minus I divided by 2n pi into, so 2 minus 2 times minus 1 power n, so 1 plus 1 is 2. So finally we get Cn is, I can take multiply this negative inside, and 2 you can take common the numerator, that 2 get cancelled. So this is I divided by n pi into minus 1 power n minus 1. So is the answer Cn. So now the question we have, if you see, there are two terms. First one is when n equal to 0. When n equal to 0, so we get C naught. So what happens C naught when n equal to 0? When you put n equal to 0, so numerator, what is happening numerator? 1 minus 1. So n equal to 0 means minus 1 power 0 is 1 and minus 1, numerator is 0. And denominator n equal to 0, 0. So 0 by 0 form you get. So that means Cn is, whatever Cn, it valid for n not equal to 0. Then what happens when n is even number, say 2k. 2k, k is 1, 2, 3, minus 1, minus infinity to plus infinity. So what happens in this case when n is even number? So minus 1 power 2k, so that can be written as minus 1 square power k. So minus 1 square is plus 1, so 1 power k is 1. So this all C2k becomes 0. So all C2k becomes 0 when n is even, whereas when n is 0 we get 0 by 0 form. So to avoid this, you know, so what I can choose, we can, since, okay, so it is observed that Cn is 0 for a even n. Okay, so I mean you should not consider R. So in even number of n values is not you should not consider, even including 0 also. So other than even numbers of n, even numbers of n, Cn is non-zero. Cn is non-zero. So that is Cn is non-zero. So this only other than even number, that means for odd number of n we get a non-zero Cn. So that means, so put n is equal to 2k minus 1. So where k is equal to minus infinity to 0, minus 1, 0, 1 up to infinity. You can choose all values of k, all values of k. So n is equal to 2k minus 1. We get only odd numbers. Therefore, I can compute c 2k minus 1, or we can write in terms of k also. So where you have to replace n by 2k minus 1. So that will be I divided by 2k minus 1 into pi into minus 1 to the power 2k minus 1. So all these values of minus 1 power 2k minus 1 is, this whole thing is minus 2. Because if you take any k, what will happen? If you choose any k, you can take k equal to, k is an odd number. Suppose k is equal to 1. So 2 minus 1 is 1. If you choose k is equal to an even number, 2. So 4 minus 1, 3. So this term we get minus 2 always. So this is minus 2i divided by 2k minus 1 into pi is the C2k minus 1 value. So that is nothing but, so this is, this also I can write ck now. So not Cn. So I can put in terms of another, so k running from, till not k, it is C2k minus 1 only, because if you take k, yeah, you can run k.
Excuse me, sir.
Yes.
So are you missing a minus, or is it just me? Cn is equal to I by n pi.
Yeah. This in the second line you are talking.
Yes, sir. The final answer, where does the minus go?
This goes to inside. So here we have, I taken this minus sign inside and 2 common. So this becomes, so minus into minus, minus 1.
Okay, sir. Understood.
Okay. So finally you can write in terms of ck answer, not Cn, because n is, now this, when you replace n by 2k minus 1, so all ck you can easily get a non-zero terms. So that will be, we have the final ck. So why this is required? The question. See, this complex number, when you take a complex series, there are some terms of Cn's, maybe 0, maybe indeterminate. So you have to identify for what value. So here, for what value of Cn's are non-zero. So only that we need to calculate, we need to obtain. So here you can state the answer. You can directly say that for when n equal to even number, Cn's are zeros. Only this is Cn is obtained for odd numbers. That also you can directly state that statement. Otherwise, for odd numbers you replace some 2k minus 1, another odd number. So in place of n, so that will run. So equation 1 now becomes f of x equals summation k running from minus infinity to plus infinity. So that is ck into e to the power minus ikx. So omega is, sorry, not minus, it is plus. Omega is 1. So that is ik plus ikx. So that is, so this gives summation k running from minus infinity to plus infinity. Ck is minus 2 divided by 2k minus 1 into pi into e to the power ik x. So this is the f of x. Now, so here, sorry. So here, what you can see, this series what we get for complex form of Fourier series, the same series you can obtain. Since the same example we have solved for the real Fourier series. So that means this function f of x, it looks like minus 1 in the interval minus pi to 0 and plus 1 in the interval 0 to pi. It looks like an odd function. So it is a odd function. Okay. So since it is an odd function, obviously even terms of even a naught, a n, all both the terms are 0. A naught and a n is 0. Only you get b n, that is b n is the non-zero term because it is odd function. So now if you think here, so what is c naught? Only first term. C naught is a naught by 2. So obviously from this calculation, from real part, c naught is 0. C naught must be 0. Even it looks like an indeterminate, we have to neglect that term. So then an. So what is an? Actually we get an is, that is 2 times cn plus c minus n in my case, I think. So if you take the negative of this in the cn, and if you add, definitely these two will be cancelled and you'll get a an also zeros. So just a cross checking. I don't ask you to do cross check each and every time. So I can validate this complex Fourier series with that one real Fourier series. So the same problem we have solved for real Fourier series, and we got only Bn term in that real Fourier series. When you introduce a complex Fourier series, you will get a function like this, a series. Okay. So any doubt in this example? Is that clear? So now we take one more example. So next one is, so one thing you remember, where once you obtain Cn, you have to cross check for is there any n value, the function, the Cn value becomes indeterminate or infinite. That you have to notice. So without noticing that, if you proceed, without noticing that, if you proceed, so this will be, you'll get a wrong answer. So here again one more term, since I replaced n by, what is that, 2k minus 1. So here this is not just a k, it should be 2k minus 1. So we have replaced n by 2k minus 1 into x. Okay, so now this is what usually the complex Fourier series gives the solutions. The series in that there's some values of n, the Cn may be infinite or may be indeterminate. So to avoid that, you have to carefully identify. So let me take one more example, that is obtain complex form of the Fourier series of function f of x is equal to cos ax in the interval minus pi to pi. So this is cos ax. So we'll take another example, cos ax. I think we have not calculated real Fourier series for this cos. So now the question is, f of x is cos ax. So x is defined in the interval minus pi to pi. So that means f of x plus 2 pi is f of x. So it's a periodic function with period of 2 pi. So we need to find a complex Fourier series for this function in this interval. So with the solution. So the complex Fourier series is that is f of x equals summation n running from minus infinity to plus infinity Cn e to the power I n omega x, called as equation 1, where Cn is defined as 1 by t integration from c to c plus t f of x into e to the power negative in omega x into dx. So we have f of x and we have the period t is 2 pi, so it implies omega, that is 2 pi by t, is 1. So this omega again in this case 1. So now I can easily compute Cn. So therefore Cn is 1 by 2 pi integration from minus pi to, so c is minus pi to pi, f of x is cos ax into e to the power I nx, so omega value is 1 into dx. So now I want to integrate this. If you go on integrating this using by parts, it never ends. So I hope you remember in plus 2 there are some expression we have. Yeah. So integration of e to the power ax into cos bx into dx. So this was the integrations you have done in plus 2. So if you remember, it is e power ax divided by a square plus b square into a cos bx plus b sin bx. So this was the result you have derived, I mean you are used. So if you remember, okay. So or what you can do, if you are not remember this, but you can remember cos ax in terms of exponential, right? So cos ax is e power iax plus e power minus iax whole divided by 2. So you can use in place of cos ax, you can use in place of cos ax either this and substitute, simplify, then integrate. If you remember this result, you can directly do the integration. So it depends on person to person. Okay. So some my memory, actually my memory is very weak. I am usually I don't remember this type of results. So what I go this basic functions and I substitute, then simplify. Yeah, it will go lengthy. If you use this second part, it goes lengthy, I know, but I'll get a correct results unless confused with the unknown quantity. Okay, so that's my drawback. Anyhow, so when I use the first result of this, so that is integration of e power ax cos bx dx is e power ax divided by a square plus b square times a cos bx plus b sin bx. So we make use of this integrations formula and that becomes 1 by 2 pi. So e power minus inx whole divided by, so here I just check, so this quantity minus in is a and this is our b. Okay, so e power ax into cos bx, so that using that, so this becomes 1 divided by a square, that is minus in whole square plus b square, that is a square, into a is again minus in cos bx, b is ax, plus b is a sin bx, that is ax. and limits from minus pi to pi. So is that clear? Now we substitute the limits and simplify. So that is equals 1 by, so 2 pi into, so this term, denominator term is constant. So minus I square. Minus I square is again minus 1. So just minus I whole square becomes plus I square. So I square value is minus 1. So this is minus 1 and that will be a square minus n square because we have n term. Okay. And now you put a upper limit. So when I put an upper limit, this will be e power minus in pi into minus in cos a, that is pi a, plus a into sin pi a, x is pi, minus lower limit, so that is minus pi, it will be e power in pi into, so that is minus in cos again minus pi a, and then plus a times sin minus pi a. Okay, so this is what after putting a limit we get. So now, so just think here, I just simplify. So there are some common terms you can do it, or some simplification. When you multiplied, okay, I'll just take next one. So that is, so Cn is equal to 1 over 2 pi into a square minus n square into, so e to the power minus, so we know that the result, I'll directly write that result, e to the power minus in pi is same as e to the power plus in pi, both are cos n pi plus I times, plus or minus I times n pi, so sin n pi. Okay, so anyhow this quantity is 0, so both we get minus 1 power n because cos n pi. So I'll directly write this is minus 1 power n, and now this becomes minus 1 power n. So what is inside? It is minus I n into cos a pi, and then plus a into sin a pi. I don't know what is a, so I should keep this terms as it is. Next lower limit, minus 1 power n into minus sin of, cos of minus theta is again cos theta, so cos a pi, whereas sin of minus theta is minus a times sin of a pi. So if I miss any terms, so please check and inform. So that will be again minus 1 power n is common, so this is minus 1 power n whole divided by 2 pi times a square minus n square, and this will be, so now we have minus in cos a pi and then plus a sin a pi. Okay, so here we have negative, so minus into minus, so we have positive, plus in cos a pi, again minus into minus, plus a sin a pi. So there are some terms which are cancelled, so in cos a pi, in cos minus in cos a pi cancelled, and we can add these two, so it will be minus 1 power n into 2 times a sin a pi, so that is sin a pi whole divided by 2 pi into a square minus n square, so 2 cancelled, So we get Cn is minus 1 power n into a into sine a pi whole divided by pi times a square minus n square. So here the condition is that a should not be equal to n. So when a equal to n, then it fails. Okay. So that means a is not an integer. It should be other than integer. So if it is an integer, then at one point it not exist. If a is an integer, say if you take a is 1, even if you take a is 1, see if you take a is an integer, new sin a pi is itself 0, right? If a is an integer, if a is integer, okay, so this result is 0 because sin 1 pi 2 pi. So because of this, so we get 0 by at exactly that a equal to some n, 0 by 0 you will get. So if you avoid this and a is not an integer, so it can so it can be an integer, but at that point Cn is not exist. So that is what at that point, so because n is also integer, at that point it is not exist. So this is one. Other than that this result is non-zero. Okay, so this is what Cn. Any doubt in Cn? I just cross check because I have taken the previous slide to here. I jumped without cross checking. Okay, a by pi a square minus n square. Okay, so now we have taken care all the terms. So finally equation 1 implies that is f of x is cos ax, that is equal to summation n from minus infinity to plus infinity Cn, that is minus 1 power n into a sine a pi whole divided by pi into a square minus n square, a square minus n square, and into e to the power plus into e to the power I n x. So this is the solution of complex Fourier X series expansion of a cosine ax. So in the interval minus pi to pi.
Sir, can you go 2 pages backwards, please?
Yeah, sure. So is that starting first problem? First, is that this slide?
Yes, sir. Slide. Yes.
Yeah.
2 minutes.
Down. Is the next slide or this slide?
This one, sir. That's it.
Okay. Any doubt?
Sir, 2 minutes, sir. I'll just copy.
Yeah, sure.
Yes, sir. Thank you so much.
Okay. So I think you have one more class is waiting. So I'll stop this discussion. I'll take So I have discussed 3 examples. Is it required? Shall I take a few more examples, or shall I take a new topic? Do you need a few more examples on this? Because I have given practice. I will take, if you want, I will take other than the practice problems.
Yes, sir. We'll do one more question.
Yeah, I will take a few more examples in the next class. Okay.
Yes,
and
sir.
then So that's all today's class. Thank you. Thank you everyone.
Thank you, sir.
Okay. Thank you all.